All right, this is part 4 of our oligopoly lecture. So now we are going to work with n greater than 2 for the number of firms, right? And we'll work off of the generic problem first, and with even n possibly greater than 3, and then back up a little bit and give some specific parameters and think about what the solution we derive here implies. So what's the main difference, right, is just coming off of this. Instead of Q, right, we can still use this generic inverse demand function where Q is the total quantity being produced, but now we're going to be thinking about Q being equal to Q1 plus Q2 plus Q3, Q4, all the way up to Qn, whatever n is, right? We have n firms, and the maximization problem or profits that we want to maximize for firm 1 are just going to be P of Q times Q1, right? That has the exact same format, C of Q1. So and with this form, note that taking a derivative for marginal revenue is going to be just like it was before, right? P prime of Q times the derivative of big Q with respect to little q, which is still just 1. So marginal revenue is P prime of Q times little q1 plus P of Q. Therefore, the profit maximizing condition for firm 1, right, is going to be P prime of Q times Q1 plus P of Q equal to C prime of Q, or marginal cost. The difference is when we start breaking this out to be able to solve for little q1, right? So if P of Q is A minus BQ, then P prime is negative B, so this is minus BQ1 plus A minus BQ1 minus BQ2 minus BQ3 and on up to Qn equal to C prime of Q1. Let's actually replace that. We'll switch to the constant marginal cost case again, just like we had here. I am sort of brushing past this. We won't think about increasing marginal costs for these n firms. You will have a question where you would need to think about asymmetry with 2 firms in this increasing marginal cost case. But yeah, so allowing us to have symmetry between all n of these firms, so they all have the same marginal cost equal to C, then this is A minus 2 B Q1. And now let's, minus BQ2 then you'll note that Q1, if we solve for that so that we have a best response function given the strategies of all of their opponents, their n minus 1 opponents, is going to be A minus C minus B times Q2 plus Q3 plus all of the little q's for however many n minus 1 other firms there are, right? Now, oh, sorry. I forgot our 1 over 2b. So that's Q1C is equal to 1 over 2b times all of that. So that would be the best response function for firm 1, right? And all n other, or n minus 1 other firms would have a similar best response function, except it would be their quantity that's over here. And in the symmetric case, this becomes fairly easy, right? Because this, if I know that firm 1, firm 2, firm 3, and any other firms are solving the exact same problem, then the point where they are all solving that exact same problem must be such that Q1 is equal to Q2 is equal to Q3. All of their solutions end up being the same, right? Therefore, at this point here, note that we cannot do this early on in the game up here before we start taking derivatives and everything. It has to be later, after the derivatives. But at this point here, I can say that Q1C equals Q2C equals Q3C. So therefore, I'm just solving for QC, right? So I am going to actually back this up a little bit to write right up here, where I have A minus 2B QC from this part of the term, and then minus, this was B times Q2 plus Q3 plus so on until Qn. Right, but if all of these are the same, QC, and this is from 2 to n, then that is just n minus 1 times QC. Combining these, I will get n plus 1, right, because it's plus the 2b from here, times b QC is equal to A minus C. There's some algebra in the middle there. But as soon as we impose that all of these Q's need to be equal to one another, we come out with this n plus 1 times Q. And then finish solving this for QC to get our equilibrium, which is 1 over n plus 1 times 1 over b times A minus C. So if, as we had over here, n is equal to 2, then that is 1/3 times 1 over b times A minus C. Note that that agrees exactly with this. If you recall what I stated in I think part 2 of the lecture, the monopoly outcome is 1/2 of 1 over b times A minus C, and that also agrees with this. Monopoly means just n is equal to 1, and then we have our case that we can also think of here with there being just 3 firms. Then it's 1/4 1 over b times A minus C, and so we can see that each individual firm's optimal quantity, QC, is going to be decreasing in the number of firms that we have, right? Compare to the duopoly case to the three-firm case, then we go from 1/3 of some value to 1/4 of some value. At the same time, we'll note, right, that that if we have n firms producing QC, then big QC is equal to n times little QC, which is, n over n plus 1 times 1 over b times a minus c. Note that n over n plus 1 is a number that is increasing in n. It may not be immediately obvious to you, but if you take a derivative of that term with respect to n, it is this is increasing in n. Why is that interesting to us, right? The problem with monopoly and with market power in general that we have is that output is restricted in order to maximize profits, which results in deadweight loss. Note that when we consider both of these two, right, what we are able to show or extrapolate here is that more firms means each individual firm produces less, but also at the same time, more firms means the total amount of output between all of those firms is increasing towards that efficient level of output, right? We could also show that this won't ever quite reach that efficient level of output, but it will approach it. So so we are moving towards the efficient level of output here for a given marginal cost and demand curve. Okay, pause for a second here to use the restroom. Okay, now, so here comes the fun part. Let's think of an example where we don't just look at the three-firm oligopoly case in this Cournot setting, but think about antitrust law, right? I think that's actually supposed to be one word, but who cares? So we'll think about telecommunications, and there are three firms in the market currently: Verschmeisen and Splint and AD&B. And Verschmeisen wants to buy Splint. So the regulators ask you to think or to estimate what the social benefits are from Verschmeisen buying Splint. Maybe I should have went with some names that are easier for me to say. So we've got a demand curve, and I'm sticking with this constant marginal cost case that we just derived these Cournot outcomes for, right, with n firms. And what I know is that there'll be some efficient level of output out here, right? So this is marginal cost, this is demand, this is QE. I know that the Cournot outcome will be something with a Q less than QE, and that's going to create deadweight loss. And I know that based on this, right, that when I decrease the number of firms, if I allow Verschmeisen to buy Splint, then then total output is going to decrease, right? Because this is going to change from 3/4 to 2/3. And 2/3 is smaller than 3/4, in case you're wondering. And so Q will decrease further. We'll call that QD for duopoly, right? So new notation, D is duopoly, C is the Cournot outcome with the 3 firms. So what I know is that allowing that merger will lead to additional deadweight loss, right? However, what I also know is that this is a sector with constant marginal costs, which means that I have cost functions of this form. And so firms are always producing at the same marginal cost, and they have some kind of fixed cost. So there will be a benefit, right, from the merger in that we should be thinking of these as some sort of per period costs. And there are still fixed costs in that sense, in that firms, in order to exist, have to pay certain costs that aren't really dependent upon how much output they have. So in the case of telecommunications, giants like this, that might include having a big legal department and having a board of directors who, you know, have to be paid and pampered and all of that. And none of that really depends on QI. So the benefit of having the merger is that the social benefit is that we'll reduce the number of fixed costs that have to be paid. So all 3 firms are currently paying F per period, and so the potential benefit is that that costs overall for this sector will come down by F. And the question that we're asking really is the additional deadweight loss created by these firms restricting their output greater than F? All right, so let's think our way through to this. First of all, with 3 firms, what I know, sorry, I was going to impose a little bit more structure here so we can have a clear example. P is equal to, we'll say, 250 minus 1/2 of Q. Right, so A is 250 and B is 1/2. And we'll also say that marginal cost, or that little c, is equal, to 10. Okay, so got marginal cost equal to 10, or c equal to 10, a equal to 250, and b equal to 1/2. And I can say QC, the quantity that each firm will produce when we don't have the merger, when there are 3 firms in the market, right, is going to be 1/4, n plus 1, so there are 3 firms, and 1 over b, if b is 1/2, is just equal to 2, right? 1 over 1/2 is 2. And then a minus c is 250 minus 10, that's 240. 240 times 2 is 480, divided by 4 is equal to, I'll put it over here, 120. So if we still have all 3 firms in the market, then total output is going to be 360, right? But if we allow the merger, then QD, now there are only 2 firms in the market. So that's going to be 1/3 times, still 1 over B is 2, and 250 minus 10 is 240. So that's 480 divided by 3, which is 160, or a total output of 320. Note, right? This should be obvious, and it agrees with what we showed earlier in this part of the lecture. But output does not fall to 2/3 of the initial output down to 240, right? Because now there are fewer competitors. Each one of them ends up producing more, but not so much more that they reach the same level of output, right? So total output has fallen, as I sort of predicted / just told you over here. And the question becomes, how much dead weight loss are we creating by shifting down here? Now, when I say dead weight loss right now, I'm only referring to dead weight loss in this sense here of the lost producer or lost consumer surplus in this. That's producer surplus, right? Because the price they're charging is up here, consumer surplus is there, and we're losing the lost surplus. It does not account for the fixed costs that now are no longer being paid. So there is another definition of dead weight loss where we could include that fixed cost there, and instead we're just going to compare dead weight loss from this space to the gain of not paying one of those firms' fixed costs. All right, so we've got these two cases, and we want to know how much dead weight loss has increased. So really, we're just interested in this triangle here, but I think the quickest, easiest, least confusing way to figure that out is just compare the difference between the dead weight loss in the two cases here, right? So what I know is dead weight loss is going to be the area of this triangle for QC. So dead weight loss for C is going to be 1/2 of QE minus QC. Right, to get the base of that triangle. Now to get the height of the triangle, I'm going to need the prices associated with each of these quantities, right? Which is nice and easy. I've got my inverse demand function up here. I just take that quantity to that inverse demand function, and I have PC is going to be equal to 1/2 of 360 is 180. So 250 minus 180 is 70. And then right here, our PD is 320. 1/2 of 320 is 160. 250 minus 160 is 90. All right, and so the height of that triangle is the area above this marginal cost curve. Marginal cost is 10. So the second half of this is PC minus MC, and we have, one thing we didn't do yet is solve for this QE, right? QE is the intersection of marginal cost with the demand curve. So this inverse demand set equal to marginal cost is 250, 250 minus 1/2 Q equal to 10, or 1/2 Q equal to 240, or QE equal to 480. That is our efficiency, our efficient outcome. Note, because of the diminishing, or the economies of scale, the most efficient way to produce that outcome would be to have a monopolist produce it, so that we avoid fixed costs for any additional firms. But the only way to make that happen would be to have a monopolist produce it with a price ceiling, and then we would have to subsidize that monopolist. So QE is 480 and QC is 360. So the difference between them is 120. and PC is 70 minus MC, which is 10, so that's 60. We get deadweight loss as 3,600. Deadweight loss for the other firm, sorry, not for the other firm, for the other case when we only have two firms, right? We allow Verschmeisen to purchase Splint, and we get 1/2 again QE, but now minus QD. So QD is 320, and 480, that's 160. And then PD minus MC for the other part of the triangle, right? I guess I can put the notation up here. PD, PC, and that PD was 90, so 90 minus 10 is 80. 1/2 of 160 times 80 is 8 squared plus 10, or times 10 squared, which is 6,400. So the change in deadweight loss when we allow the merger, right? Delta deadweight loss is equal to deadweight loss after the merger minus deadweight loss before the merger, which is, let's see, 40, 44, 28. Whoops. So what we might say is that if F, the fixed cost for a single firm to operate in this market, is in the vicinity of 2,800, then the merger is kind of okay, right? The net benefit is approximately 0. If F is less than significantly less than this, then the additional deadweight loss is greater than the benefit of having of getting rid of some of those, we'll call them administrative costs, those fixed costs associated with that third firm existing. So if the additional deadweight loss because of restricted output is greater than those savings, well then the merger is no good. If F is, say, 3,000 or 4,000 or anything greater than this amount, then the deadweight loss from restricted output is worth the gains of saving on total fixed costs in this sector, right? So comparing a specific case between 2 and 3 firms is all we did here, right? And the total level of output and the prices in the market, right? If we go from 3 firms down to just 2 firms, the price increases and the total quantity supplied by the 2 firms decreases, increasing the deadweight loss. But with these constant marginal costs and some positive fixed costs, there is also this gain that we should keep in mind of unnecessary fixed costs that we have to get rid of, or that we save those fixed costs that would have to be paid for the third firm to operate. All right, so your end recommendation would be dependent upon, and this is the type of question that we could ask, right? What range of F would we recommend that the merger be allowed? And that would be if F were equal to or greater than 2,800, right? Okay. I almost asked if there are any questions, but you'll have to get back to me with those via email if you have any. And we'll be back with one more section to the lecture in just a moment.